Lakshmi Prasanna, Assistant Professor, Department of ECE, Institute of Aeronautical Engineering. In this session, we will discuss about serial port operation that is done in 8051 microcontroller. So, we will discuss about what are different registers that will be there in the serial communication, and we will see how that registers will be operated in order to configure the serial port. And we will see what are different modes of operation. But before going to that concept, we have to see some small introduction regarding communication. So here first, what is meant by communication? So here communication means interchanging of information between sender and receiver. And we can also define this communication as a common method for transmitting the data between computer and peripheral devices. So transferring the data between computer and peripheral devices can be called as communication. Now, so here there are two types of communication. One is serial communication and another one is parallel communication. Coming to the serial communication, here we will see how the data is transmitted between this transmitter and receiver. So in the serial communication, we will have a single wire between transmitter and receiver. So using that single wire only, the data will be transmitted from the transmitter bit by bit. So first the LSB bit will be sent, and next the next bit will be sent. Like that, bit by bit transmission will be performed by using this single wire, and at the end the MSB bit will be sent. Now here in this type of communication, while the data is transmitting, we have to consider the clock signal also. So for transmitting each bit, one clock pulse should be required. Now, another type of communication is parallel communication. So in this type of communication, how the data is transmitted between transmitter and receiver. So here the name is about parallel communication. For the transmitter, in order to transmit the data, it uses n number of wires. So here to the transmitter, we can observe there are n number of wires. Okay, so like that there are n number of wires. So using this n number of wires, n number of bits will be transmitted at a time. Okay, and while transmitting this bits from transmitter to receiver, we have to see that the clock signal should be enabled. So in the parallel communication, at a time, all the bits will be transmitted from transmitter to receiver. But whereas in the serial communication, data will be transmitted bit by bit because there is only one single wire. Now we will see in which type of devices we are going to consider serial communication and in which type of cases parallel communication is preferred. Now, so these are some of the differences between serial communication and parallel communication. So in the serial communication, data is sent in the bit by bit format by using one clock pulse. That means each bit uses one clock pulse. But whereas in the parallel communication, bulk of data will be transmitted because there are n number of wires. Now, to transmit the data in the serial communication, transmitter requires only one wire. But whereas in the parallel communication, in order to transmit n number of bits at a time, the transmitter requires n number of wires. So serial communication, the data transmission speed is slow. Why? Because using single wire only we have to transmit the bit. So bit by bit transmission is done there. That is why communication speed is slow in the serial communication. But whereas in the parallel communication, since all bits are transmitted at a time, the communication speed increases. Now, here serial communication is preferred for long distance communication, whereas parallel communication is preferred for short distance communication. And another difference, if you take an example, in order to have communication between this computer and computer, we are going to consider serial communication in between the two devices. But if the data transmission or if the communication is performed between computer to some peripheral devices like IO devices like printer, between these two, we will have the parallel communication. So these are some of the basic differences between serial communication and parallel communication. So since the serial communication is preferred for long distance communication, compared to parallel communication, serial communication is preferred. Now, so that is why now we will see what are different transmission modes, serial data transmission modes. Okay. So out of serial communication and parallel communication, serial communication is widely preferred to transmit the information between the transmitter and receiver. So it may be either data communication between the processing equipment and any other peripheral devices. And so when this serial communication is preferred, the data transmission can happen in many forms. So it depends on the type of transmission mode and the data transfer. So based on these two, we will see now in how many forms the data will be transmitted. That means serial communication will be performed. So here there are different transmission modes. So different transmission modes are, the first one is simplex transmission mode, next one is half duplex transmission mode, and another one is full duplex transmission mode. So these two communications comes under duplex communications only, but there is a small difference between this half duplex and full duplex communication. Now, so we will see about these three transmission modes now. So this is the basic diagram that shows how the transmission modes are classified. Now, so if you consider here, this is a network, and if you want to make the communication between this computer and another computers, any of the transmission mode can be preferred. Now, so if the transmission type is of simplex transmission, that is the basic transmission mode. So in the simplex transmission mode, it is called as one-way communication. Why? Because every time the sender will be sending the data and the receiver will be receiving the data. So in this case, there is no chance of receiver to send the data to the sender. So that is why it is called as one-way communication. It is also called as simplex communication. And another transmission mode is half duplex transmission mode. So in this half duplex transmission mode, we will see how the data is transferred between sender and receiver. So in this type of transmission mode, the sender will be sending the data and the receiver will be receiving the data. In the second case, the receiver also can send the data to the sender. So in the half duplex communication, two-way communication will exist. But in this case, two-way communication is not performed at a time. That means when the sender is sending the data, the receiver has to receive it. After completing that only, after receiving the complete data, then only the receiver can send the data to the sender. It is two-way communication, but not at a time. And another serial transmission mode is full duplex transmission mode. So in this type of communication, this is also called two-way communication. But here the two-way communication can be performed at a time. So the sender can be sending the data at the same time. The receiver also can send the data to the sender. So full duplex means it is two-way communication. The communication will be existing at a time. Now, so coming to the first transmission mode, that is simplex method. It is a simple connection. So in this case, data is transmitted in one direction only. So for example, you can take printer. So the communication that can be done between a computer and printer is a simplex method. That means every time the computer will be sending the command to the printer and the printer will be operating. So there is no chance of giving printer command to the computer. And another transmission mode is half duplex mode. So in the half duplex mode, it is called two-way communication, but only in one direction at a time. So for example, the internet connection can be considered as a half duplex transmission mode. So how means if a client sends a request for the web page, the web server processes that application and it sends back the information. And the next transmission mode is full duplex mode. So this is the most commonly and widely used communication mode. And why? Because here both sender and receiver can transmit and receive the data at the same time. And example, smartphone comes under this full duplex transmission mode. So these are different transmission modes that is supported by serial communication. Now we will see what are different serial data transfer schemes that are available in the serial communication. So generally there are two ways to synchronize the two ends of communication. So what are the two ways here means? One is synchronous data transmission. Another one is asynchronous data transmission. So the main difference between this synchronous and asynchronous data transmission is clock signal. So what is meant by synchronous transmission means, in synchronous transmission, data will be sent in the form of blocks or frames. And so this synchronous data transmission supports full duplex transmission mode. And so between sender and receiver, the synchronization should be compulsory done. So that is why in this case, the external clock signal will be used. In this synchronous transmission type, since the data is transmitted in the form of blocks or frames, there will not be any gaps present between the data. And that is why it is more efficient and more reliable compared to other data transmission, that is asynchronous data transmission mode. In order to transmit large amount of data. So to transmit large amount of data, it can be transmitted in the form of blocks or frames by using this synchronous data transmission. So here we can consider this is sender and receiver, where the data is transmitted in the form of blocks or frames. So you can consider here this is the data. Between this data there are no gaps present. So that is why large amount of data can be transmitted. So in the synchronous data transmission, so in order to have that synchronization, we have to use the clock signal. So this is the clock signal, and the data what we are transmitting, consider for example 61H. Okay. So this is called the falling edge of the clock. Okay, and this is called the rising edge of the clock. So based on the falling edge of the clock and rising edge of the clock, the transmitter and receiver will be getting synchronized. Okay, so because here you can see during a falling edge of the clock, transmitter is going to send the data, whereas at the rising edge of the clock, the receiver is going to receive that particular data. And coming to another type of data transmission, that is asynchronous transmission. So in this case, data will be transmitted in the form of byte or characters. So this type of transmission supports half duplex communication. So here, since the data is transmitted in the form of bytes or characters, we can observe the gaps present between the data. In that gaps, the stop bits and start bits will be added. Okay. So why? Because in the asynchronous transmission, we will not have an external clock signal. In order to have synchronization between transmitter and receiver, it is possible by adding this start bit and stop bit to the original character. And it does not require any synchronization. So if we consider here, this is the sender and receiver, where the data is transmitted in the form of character, byte or character. So for this data, we can see here start bit and stop bit is added. Like that, for each byte or character, one start bit and stop bit will be added. So here start bit will be indicated with a 0 and stop bit will be indicated with 1. So this is the figure we can see. In this case, there is no external clock signal indicated. But here, in order to transmit the data 61H, it is going to use the internal clock signal. Okay. So here, the transmitter uses an internal clock when to determine and when to send each bit. And so the receiver, at the next cycle, the receiver is going to detect the falling edge of the start bit, and it uses its internal clock to read the following bits. So this is how the transmitter and receiver will be synchronizing by using the internal clock signal. So these are the basic differences between the synchronous transmission and asynchronous transmission. So in the synchronous transmission, data will be sent in the form of blocks or frames, whereas in the asynchronous transmission, data is transmitted in the form of byte or character. So synchronous transmission is fast, whereas asynchronous transmission is slow. And synchronous transmission is costly. And here asynchronous transmission is very economical. In the synchronous transmission, time interval of the transmission is constant, because in this case, the external clock signal will be used. Whereas in the asynchronous transmission, time interval of the transmission is not constant, it will be random. Why? Because here in this case, external signal, clock signal is not used. So in the synchronous transmission, there is no gap present between the data. But whereas in the asynchronous transmission, there will be gap present between the data in order to add the start bits and stop bits. So that is the small introduction. Now coming to the serial port operation. Here, first we have to know what are the basic components of 8051 microcontroller. So we can have here one microprocessor, RAM, ROM, IO port, timers. Okay. Now we are going to talk about this serial communication port. So all these components will be embedded inside 8051 microcontroller. So here it consists of RAM, what its size is 4 kilobytes, and internally the RAM is available. Internal RAM size is 128 bytes, and it consists of 4 IO ports. Each port size is of 8-bit, and it also consists of 2 timers. Each timer size is of 16-bit. And at last it consists of one serial port, that is one serial communication port UART is available. Now, coming to the features of 8051 microcontroller, it is having 8-bit data bus. That is why 8051 microcontroller is called 8-bit microcontroller. And it is having 16-bit address bus. And 4 register banks are available. Each bank size is of 8-bit. And the 4 register banks are here: bank 0, bank 1, bank 2 and bank 3. And it consists of 32 general purpose registers. Each register size is of 8-bit. And it consists of 2 important registers: program counter and data pointer. Program counter is a 16-bit register and data pointer is also 16-bit register. And internally it is having memory ROM, which is called program memory, and its size is 4 kilobytes. And internal RAM is available, which is also called as data memory, and its internal size is 128 bytes. And 2 timers are available, each is of 16-bit in size. And 4 ports, IO ports are available, each port size is of 8-bit. And along with that, interrupts are also available, 3 internal and 2 external interrupts, and 1 serial communication port. So we are going to talk about this serial communication port, UART. And bit as well as byte addressable RAM area is available, which is of 16 bytes. And so 1 mission cycle is equal to 12 clock pulses. Now, coming to the serial port operation. So in this serial port operation, to perform the serial port operation, here we have to use 2 important pins. One is TxD, another one is RxD. So TxD represents transmit data and RxD represents receive data. So 8051 has 2 pins that are used especially for transferring and receiving the data serially. So 8051 microcontroller is a 40-pin IC. Among that 40 pins, 2 pins are RxD and TxD. That 2 pins are used for transferring, that is TxD pin, and receiving by using RxD pin. And so this TxD pin and RxD pin, it is related to port 3 pins of 8051 microcontroller. Especially if you see port 3 pins, each pin is having its own operation. So P3.0 and P3.1. These are the 2 port 3 pins which have another function other than IO port, that is TxD and RxD. And so these pins are TTL compatible. That means they will be operating only with TTL voltage levels. But before communicating that, before transmitting that into the channel, the TTL should be converted into RH232. Then we have to transmit. Before receiving, that RH232 should be converted into TTL levels and then only it should be received. So in order to perform this transmission, it should have line driver and line receiver ICs. And next what we have to see is PC baud rate to perform the serial port operation. So one is TxD RxD pins, another one is PC baud rate. Now, so here PC, it is compatible computers which is of having Pentium microprocessor. Normally, those computers will be having 2 ports. So both the ports are RH232 type connectors. What are the 2 ports means? COM ports they are. It is designated as COM1 and COM2. But for now, these ports are replaced with USB ports. Now, to allow the data transfer between PC and 8051 microcontroller without any error, we have to make sure that the baud rate of 8051 microcontroller and the baud rate of PC COM port should be matched with each other. So if the baud rate is matched between these two devices only, the data transferring can be performed without any errors. So we have to see that the baud rate should be matched. Now, how to set the baud rate in 8051 microcontroller? So here, baud rate in 8051 microcontroller is having a programmable relationship between the crystal frequency and baud rate in 8051 microcontroller. So we will see what is the relationship. Now, so if you see here, this is the crystal oscillator. So the frequency of this crystal oscillator is 11.0592 megahertz. So this crystal oscillator frequency will be divided by 12. Okay. So why it should be divided by 12 means because one machine cycle consists of 12 pulses. So when this 11.0592 megahertz is divided by 12, the resulting frequency what we are going to get is 921.6 kilohertz. Even this 921.6 kilohertz frequency should be divided by 32 before giving to this timer 1. Okay. So this 921.6 kilohertz divided by 32 means we are going to get this 28.8 kilohertz frequency. That frequency should be given to the timer 1. So why we have to do all this complete procedure means in order to set the baud rate. Okay. So here we have to notice that first the crystal oscillator frequency should be divided by 12 and that frequency whatever we are getting should be divided by 32. Okay. So this is the default value we are going to get when 8051 microcontroller is reset. So this is the procedure we have to follow in order to set the baud rate. Now, so for example, if we consider here, the crystal oscillator frequency is 11.0592 megahertz and we have to find the value of this TH1 that should be needed in order to produce the following baud rates. Okay. So here these are the baud rates they are given. We have to find what is the value of this TH1. So as we know, the given crystal oscillator frequency is 11.0592 megahertz. And based on the previous procedure to set the baud rate, first that frequency should be divided by 12. We are going to get 921.6 kilohertz. And that frequency should be divided by 32 in order to get this baud rate, frequency in order to set the baud rate. Now we have to consider this frequency and we have to find the value of this TH1, okay, with the help of this given baud rates. So if you see first here 28,800 is the frequency what we got and the baud rate given is 9,600. So in order to get this value, we have to divide the value by 3. Okay. And here minus 3 is the value we will get because it is in the denominator. And that minus 3 if we convert into hexadecimal, its value is FD. That value should be loaded into this TH1 in order to get the baud rate 9,600. So similarly, the same 28,800 frequency should be divided by 12 in order to get this 2,400 baud rate. So here this is 12 in the denominator. So the value of minus 12 is F4 in the hexadecimal. This F4 value should be loaded into this TH1 in order to get 2,400 baud rate. And the third one is, in order to get this 12,000 baud rate, the frequency should be divided by 24 and the hexadecimal value of this 24 is E8 and this E8 is the value what we have to load into TH1 register. Now, so that is how we have to set the baud rate. Okay. Now we will see what are different registers that can be used in order to perform the serial data transfer. One is SBUF register. It is an 8-bit register, but it is not having particular format. So here SBUF represents serial data buffer. Another register is SCON register, which stands for serial control register. It is an 8-bit register. And the last one is PCON register, which is called as power control register. Now we will see about the 3 registers in detail, which are used for providing the serial data transfer. First register is here SBUF register. So we will see how this SBUF register will be present at the transmitter and receiver ends. So the byte of data to be transferred through this TxD signal, first it has to be put in the SBUF register and then it has to be transmitted. So at the receiver end, at the receiver also, one SBUF register will be there. Okay. So while the data is received by the receiver, it will be first kept in the SBUF register, which is present at the receiver end. So like however the general purpose registers we are using like A, B, in the same way in the transmitter and receiver side, we can use this SBUF register in order to store the data temporarily at the transmitter end and receiver end. Now, so in order to say simply here, if we consider this is the transmitter and here this is the receiver. Okay. So at the transmitter end, you will have one SBUF register. Before transmitting through TxD pin, it will be placed in the SBUF register. And after it is received through RxD signal, it will be first put in this SBUF register, which is present at the receiver end. Now, so move SBUF, #D. If we write here, what is the operation that will perform means it is going to load this value into SBUF register. So here ASCII value of D is 44. That is why 44 value will be moved into SBUF register. Anyway, 44 is an 8-bit data, SBUF is an 8-bit register. Move SBUF, A if you write. So it is going to copy the content which is present in accumulator into SBUF register. Move A, SBUF means it is going to copy the content which is present in SBUF register into accumulator. And so when the byte is written into SBUF register, that means when we are storing the data in this SBUF register, we are going to that original data, we are going to add the start bit and stop bit at the transmitter side. Now, so when the bits are received through RxD pin at the receiver end, the data should be stored again in the SBUF register. But before storing the data, it has to see that the stop bits and start bit should be deframed. That is, we have to remove the start bit and stop bit, and then it has to store in the SBUF register. So making a byte out of the data received and then place in the SBUF register. That means we have to remove that start and stop bits and then it has to store in the SBUF register. So SBUF register is physically of 2 registers. One is used to write the data. Writing means transmitting. So that is why it is going to hold the data at the transmitted side of this 8051 using TxD pin. Another register is read only. Reading means receiving. Okay. So through RxD pin, it is going to receive and put in that SBUF register. So both manually exclusive registers have the same address 99H. So this SBUF register is having a fixed address 99H in the SFR address space. So this SBUF, it is not bit addressable register. Now coming to another register that is available in serial port operation, it is SCON register. So this SCON register is a 8-bit register. So all these are the 8 bits. So this is D0, D1, D2, D3, D4, D5, D6 and D7. So all these are the 8 bits that are present in the SCON register. So it is an 8-bit register used to program start bit, stop bit, data bits and data framing among other things. So this is the format of SCON register. Now, so what is the main purpose of this SM0 bit means? It is used for it is used to specify the serial mode. That is whether it has to run in mode 0, mode 1 like that. Another one is SM1. So these 2 bits together says the mode of operation. And when you are going to use this SM2 means it is used for multiprocessor communication. And next bit is here REN. It is used for setting and clearing. Okay. So setting and clearing can be done by using software. This bit is mainly used for enabling and disabling the receiver. Another bit is TB8. It is not used in mode 1. And RB8 is also the bit which is not used in mode 1. And next 2 bits are TI and RI. So TI represents transmit interrupt flag. It is set by hardware at the beginning of the stop bit and it will be cleared by software. So similarly RI means receiver interrupt flag. It will be placed at the receiver end. And as we have seen, the D7 and D6 bit in the SCON register, it is SM0 and SM1, which specify the mode of operation. So how the mode of operations differs means based on the size of the character and based on the addition of the start bit and stop bits to that particular character. So if this SM0 and SM1 both the bits are 0, 0, the mode of operation is mode 0. If it is 0, 1, mode 1 operation, 1, 0, mode 2 operation and 1, 1, mode 3 operation. So here there are 3 modes of serial operation. So these are the 4 serial data communication modes of operation based on that SM0 and SM1 bits. Now coming to mode 0 operation. Mode 0 is having the following features. So in this mode both the transmitter and receiver will be operating with the same clock frequency. So serial data enters and exits through this RxD pin and transmitter clocks out the clock signal and 8 bits are transmitted and received. So these are the 8 bits that will be transmitted and received. The baud rate will be fixed at 1 by 12th of the clock frequency and it will be running in the synchronous mode and it acts as a shift register. So these are different features when it is operating in mode 0. So when it is operating in mode 1, it has the following features. So in this case, the serial data enters through RxD pin and it exits through TxD signal. And upon receiving, the stop bit goes into RB8 bit. So in SCON register, this RB8 is one of the bit. And so here 10 bits will be transmitted and received. So what are the 10 bits means? Here we can see 8 bits are related to the data, that is character. To this 8 bits, we are adding this one start bit and one stop bit. So totally 10 bits will be transmitted and received. So in this mode 1 operation, baud rate will be determined by the timer 1 overflow rate. So if we observe, this figure will clearly show that the character length is of 8 bit. To this 8 bit data, we are going to add the stop bit and start bit such that the size of it will be totally 10 bits. So that is what the features of mode 1 operation. Another mode of operation is mode 2, having some following features. So the serial data enters through RxD pin and the serial data exits through TxD pin. And so 9th data bit in the SCON register, that is TB8, it can be assigned to a value either 0 or 1 when it is operating in mode 2. So upon receiving, the 9th data bit goes into RB8 in the SCON register. Here, totally 11 bits will be transmitted and received. We will see how the 11 bits are classified. So 9 bits are related to the data bit, that is character. To that 9 bits, we will have one start bit and stop bit, so that the total length will be 11 bits that will be received and transmitted. So here this is the format which shows that 11 bits totally. So here this is 1 to 9. 9 data bits are there. Character length is 9. To this we will have one start bit and stop bit added. So totally 11 bits will be transmitted and received in this mode 2 operation. So in this case, the baud rate is programmable. It is not set by the timer overflow rate. Now, the next mode of operation is mode 3, having the features like serial data enters through RxD pin and exits through TxD pin. So this RxD and TxD, these are the two signals that are used for serial communication. So in this mode 3 operation, 9th data bit, that is TB8, can be assigned to a value 0 or 1. So this TB8 is one of the bit in the SCON register. Upon receive, the 9th data bit will be going to the RB8 bit of SCON register. And in this case also, the number of bits are 11 that can be transmitted and received. So the 11 bits are 9 related to the data and one stop bit and start bit will be added to that. So totally the character length will be 11. And same figure will be similar to mode 2 operation. So in this case, the baud rate is determined by the timer 1 overflow rate. Whereas in mode 2, baud rate will be determined by the, it is programmable. Now, so here the important 2 bits in the SCON register is, one is TI, another one is RI. Transmit interrupt and receive interrupt. What is the importance of these 2 flags means? First flag is TI, transmit interrupt. So whenever 8051 finishes transmitting the complete 8-bit character, it is going to enable this TI flag bit saying that it is ready to transfer another byte. So TI bit will be raised at the beginning of each stop bit. And RI is receiver interrupt. So when 8051 receives the data completely through RxD pin, it is going to enable this RI flag bit which is present in the SCON register. And RI is raised halfway through the stop bit. And another serial port register is PCON register. So here this PCON register, if you observe, it is an 8-bit register. So here are the 8 bits. First bit is SMOD. So this SMOD indicates baud rate. It is used to set the baud rate. The baud rate will be twice as much higher. Okay. Another 2 bits are GF1 and GF0, which are called general purpose bits. And so generally the microcontroller is inactive. Why this PCON register is used means the microcontroller is inactive for the most part and it has to just wait for some external signals in order to take its role in the show. Okay. So this can cause some problems in case of batteries that are used for power supply. So in these cases, what is the solution means? we have to set the whole electronic into sleep mode in order to minimize the power consumption. So here the PCON register can be operated in two power control modes. Here one is ideal mode. Okay. So what is ideal mode means? So if you see PCON register bit format, we can observe one bit which is called ideal. Okay. So this ideal bit is used to set the power saving mode in the ideal mode. So when this ideal bit in the PCON register is set, the microcontroller is going to turn off the CPU, whereas the remaining peripherals like serial port, timers, interrupts, anyway they will be operating in the normal way. So in the ideal mode, all the registers and IO ports remains unchanged. And the another one is, in order to exit from the ideal mode and make the microcontroller operate normally, just we have to press the reset button. So it will cause this ideal bit in the PCON register cleared and the power resume operation from instruction having set the ideal bit. And another power saving mode is power down mode. So here in the PCON register, again we can observe one bit which is called PD bit. So this PD bit of the PCON register, when it is set, the microcontroller will be operating in this power down mode. So in the power down mode, internal oscillator is off and it is going to reduce the power consumption. The only way to get the microcontroller back to the normal mode of operation is by simply clicking the reset button. Now, so in the power down mode, while the microcontroller is operating in the power down mode, the status of this special function register, IO ports, all these register status will remain unchanged. So by setting back this 8051 microcontroller in the normal operation mode, the content of this SFR register will be lost, but the content of internal RAM will be saved. So this is what about the serial port operation of 8051 microcontroller and the registers that are configured during serial port operation. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.